All right, welcome to our final presentation. Today I'm joined with Elizabeth, Riley, and Una. My name's Amanda, and we're going to be investigating the extreme heat and human health risk in the face of climate change and looking into a potential climate justice issue.
Okay, so for introducing our key variables are heat change and health impacts. So extreme heat refers to unusually high temperatures that exceed the historical average for a specific region. As global temperatures rise due to climate change, periods of dangerous heat are becoming more frequent. These conditions pose threats to human health, particularly in vulnerable populations. And for health impacts, prolonged heat exposure is associated with increased mortality and hospitalizations. The body struggles to regulate its temperature during these extreme conditions. This is specifically seen to negatively impact elderly and low-income populations. For the significance, the relationship between rising temperature and human health outcomes is understudied, regardless of evidence linking the two. More research and education is necessary to protect vulnerable populations from the health risks associated with climate change.
So these are our three research questions. Our first research question is which World Health Organization region have the most burden of heat-related mortality, and has this changed over time? And then our second question is there a relationship between the temperature anomalies and heat-related mortality across different regions? And then our third question is there a relationship between CO2 emissions and heat-related mortality across World Health Organization regions?
Okay, moving on to our data sources. So our first data source, we got it from Lancet Countdown, which is an international research collaboration that independently tracks the health impacts of climate change. And we specifically found a data source telling us the number of heat-related mortalities globally, and then specifically by WHO region, which is how we're measuring most of our data. This is the raw data table. The next slide shows the clean data table, and it's the exact same thing because this data didn't need any cleaning. Our second data source is from Our World in Data, which is a highly regarded data source. And we found the annual temperature anomalies, and this is by country for raw data, but the temperature anomalies are measuring how much warmer or cooler a year is compared to normal. So a warmer year is a positive anomaly, and a negative year is a cooler year is a negative anomaly. And then the next slide is going to show the cleaned data source. And we did this by taking the averages of the countries in each WHO region so that we were able to compare with the heat-related mortality data set. And then our third data source is also from Our World in Data, and it tells the annual CO2 emissions, so we could look specifically if there's a link between emissions and increase in temperature. And this is also by country, it's the same source. So this is the raw data table. And then in the next slide, we'll show the clean data table, and it'll show we went through the same process of taking the averages across each country so that we could see the numbers for each region by each year. And then our fourth data source is just what we used to categorize each country into each region. And it's the world regions according to the World Health Organization, which are 6 groups established by the World Health Organization for coordinating surveillance and policies specifically in the health world. So our next slide, yeah, it should show a map so you can visually see each region. The orange is Americas, purple is Africa, tan is Eastern Mediterranean, dark blue is Europe, green is Southeast Asia, and then light blue is the Western Pacific region. Moving on to the descriptive statistics, this one's for mortality data. And from here, we can see that Southeast Asia has the highest number of mean deaths, followed by Africa, and then America has the lowest number of mean deaths. And then our next slide will show a box and whisker plot that shows specifically this data. So you can visually see the difference. And then America has the lowest, so it's the safest in terms of heat-related mortality. Um, our next our next table for descriptive statistics are temperature anomalies, and from here we can see that Eastern Mediterranean and Europe regions are the most volatile, and it will be interesting to see if this will correlate with the death spikes in mortality. And then the Western Pacific is the most stable, and we can see a positive skew in each region, which basically tells us that the warming trend of global warming is consistent and real across the globe. So the next slide will show a visual graph of this data trend. And then our final table shows the CO2 emissions. And from here, we can see that the Western Pacific region is the largest emitter, and then Africa is the smallest emitter, um, which might challenge the CO2 to deaths narrative that kind of persists. And then all regions show a positive skew, which shows that the problem is getting worse. And then the next one shows a visualization of this. So we can see that the Western Pacific is the highest, and then Africa is the lowest by far. And then finally, our key data table. From here, we can see that the Eastern Mediterranean region has the highest or the clearest link between warming and then heat-related mortality. But the overall broader pattern, because we're not seeing too much relation between these, says that the heat-related deaths may be driven by more than just temperature anomalies and CO2 emissions. It also could be driven by things like regional vulnerability and then adaptive capability in each regions.
Okay, to get into our research questions, again, our first question is which WHO regions have the highest burden of heat-related mortality, and has this changed over time? So we did a line chart to display the heat-related mortality across all 6 WHO regions from 1990 to 2020. Southeast Asia consistently had the highest number of heat-related deaths, followed by Africa, and this shows a clear upward trend over time. While all regions show year-to-year variability, there's an overall increasing pattern across all 6 regions. This indicated heat-related mortality has worsened globally from 1990 to 2020. And then here we have a bar chart of just 1990. This bar chart shows heat-related deaths across all WHO regions for 1990. Southeast Asia has the highest heat-related deaths in 1990, followed by Africa, then the Eastern Mediterranean, Western Pacific, Europe, and then the Americas. But overall, heat-related deaths in 1990 are all below 100,000 deaths. So still significant, but not as many as today. And then here's the bar chart of 2020 to compare. There is an increase in every region from 1990 to 2020. Africa showed the largest increase by 2020, nearly tripling its deaths across 30 years. And overall, heat-related deaths are significantly higher, with some regions reaching as high as 180,000 deaths in 2020. And every region experienced an increase in heat-related deaths, suggesting that the global issue of heat-related mortality has worsened across all areas over time.
Okay, so question 2 is there a relationship between temperature anomalies and heat-related mortality across different regions? So our first visualization is a scatter plot, which examines the relationship between temperature anomaly and heat-related death across all 6 WHO regions from 1990 to 2020. Temperature anomaly just measures how much warmer or cooler a given year was compared to the historical average. What stands out is that across every single region, as temperatures rise, heat-related deaths rise as well. The regression lines and R-squared values back this up statistically. Looking at specific regions, Africa shows the strongest and most consistent relationship with an R squared of 0.86. Southeast Asia has more variability around its line, but it has the highest death tolls, nearly 300,000 in some years. Rising temperatures mean more deaths everywhere, but the scale of this relationship is different depending on where you are in the world. And then this is just the same data shown without the regression lines for clarity. And again, the scatter plot shows all 6 WHO regions from 1990 to 2020. And then these are 2 line charts comparing total global heat-related deaths and global average temperature anomaly trends from 1990 to 2020 for comparison. So these 2 line charts track total global heat-related deaths and average temperature anomaly from 1990 to 2020. The temperature anomaly shown in the bottom chart rises pretty consistently over the 3 decades, especially from like the 2000s onwards. And heat-related deaths are much more unpredictable, with noticeable spikes around 1998 and 2010. And those correspond well with extreme heat events around those years. And then even though temperatures increase gradually, the deaths don't follow the continuous pattern and they spike in specific years. This suggests that it's not just average temperature rising driving mortality, but heat events around these times increase the death toll suddenly. So the main takeaways is that as baseline temperatures continue to rise, extreme heat events become more likely, which typically result in death.
All right, and for our third research question, which asks whether there is a relationship between CO2 emissions and heat-related mortality across WHO regions. So, in this first scatter plot, it displays that CO2 emissions on the y-axis and heat-related deaths on the x-axis, and then the heat-related deaths on the y-axis. With each point colored by WHO region, there's no clear positive correlation between the 2 variables, but Southeast Asia shows the highest heat-related deaths across a wide range of emission levels, indicating that high mortality even at moderate emissions. Countries with the highest CO2 output tend to cluster towards the lower end of the heat-related deaths. And then for the next one, for these 2 bar charts, so these compare the 2 variables side by side for 2005. In the heat mortality chart, Southeast Asia recorded the highest deaths at 204,073, followed by Africa at 170,149. In the emissions chart, the rankings are completely reversed. Western Pacific had the highest CO2 output, while Africa had the lowest emissions. And then in this next slide, this comparison basically just confirms that CO2 emissions and heat-related mortality do not follow a positive correlation. The regions with the highest emissions tend to have fewer heat deaths, while lower-emitting regions bear a greater burden. This suggests that factors outside of a region's own emissions, such as healthcare access, infrastructure, and economic resources, may be more influential in determining mortality outcomes. And then for our conclusions and key findings, heat-related mortality increased across all 6 WHO regions between 1990 and 2020. These temperature anomalies consistently correlated with higher death counts, which then higher CO2 emitting regions do not experience the most deaths, while lower emitting regions carry a disproportionate burden. And then key findings include Southeast Asia averaging 163,000 deaths per year, Africa ranking second despite low emissions, wealthier regions recording the fewest deaths, and a global peak of 721,588 deaths in 2010, corresponding to a major temperature spike. And then for our limitations and further explanations, there are several limitations to note. Heat deaths are underreported in lower income countries. Confounding factors such as age, urbanization, and healthcare access are not accounted for in our analysis. CO2 data does not align precisely with WHO regional boundaries, and 2020 data may be affected by COVID-19 disruptions in health reporting. And future work can include examining adaptive capacity indicators, extending the dataset beyond 2020, and studying whether heat exposure in one year influences mortality in subsequent years. So with that, thank you.